Okay, today we are reviewing the concept of gradient. Our important thing to do today is to be able to calculate, interpret, and apply the concept of gradient. Hopefully, everybody should have seen the idea of gradient or slope before, and have some idea about this. I think we do it from grade 8 onwards, and it comes back a few times. So let's have a look at this one. Let's see what we know. So here on this example, we're asked to determine the gradients of the lines shown. Now there's a couple of techniques and strategies you can use to do this. There are a couple of techniques and strategies to do this. One of the easiest ways is to sort of look on the line and do a slope triangle. So what we've got to do is we have to look at this graph and to see where the graph is actually crossing the axes. You can see that it's crossing the axes at these 2 points here. It's not crossing them all, so sometimes you can't necessarily read off the other ones. They might be halves, but they might be thirds, and you can't always read it. So look up along the graph and find where does it cross the line. So it crosses at these 2 points. And what we want for the gradient is we use the gradient formula, which is m is equal to the change in y over the change in x. This formula is the easiest, the quickest to use. What it means is how much is the y value changing, how much is the x value changing. When you're looking at the change in the x values, it's going across by +2. Always have the x going from left to right. So we know that the x value is increasing by 2. This means the x value is always going to be positive. So the change in x is always going to be positive. The x value is changed by 2. How much does the y value change in that period? Well, it goes down by -1. So the gradient here is -1/2. The gradient here is -1/2. An alternative to this method would be, there is a more detailed method that we can use, and we can say that the gradient is equal to y2 minus y1 over x2 minus x1. So what we have to do for this method is we have to read off a couple of coordinate points. So the process is similar. We just need to find the coordinates of these points. This one is at 2, 5, and this one is at 4, 4. You then decide which is x1 and x2 and so on. Always use the one to the right as x2. So always have this one as your second coordinate and this one as your first coordinate. That means your change in x is going to be positive. You want the change in x to be positive, it's a little bit easier. It doesn't make any difference and it won't particularly matter. Now using this formula you often make mistakes. You put typically the mistake that students make is, there's a variety of them, but this is the most common one, is they put them in upside down. So this is wrong. Don't do it like this, putting them in upside down with the change in x over the change in y. But as students know, there's many ways that they can mess things up. And another common one would be to have y2 minus y1, but on the bottom have x1 minus y2, something like this. Usually making both the values positive or something, or just exchanging one of these completely, messing it up horrifically. So a bit of practice on this and figuring out where you make mistakes helps reduce the errors that you're making. So we put the values in, and we've got y2 is equal to 4, y2 is equal to 4, y1 is equal to 5, and then we have 4 minus 2, which gives us -1 over 2. Have a go at finding, for b, the gradient of this one using one of these two techniques. Let me see it written down on your page. use the slope triangle. Sorry? Yeah. Try to use the slope triangle. I think it would look like so much quicker. So much quicker.
Sir, can you explain how to do like the change in, like if I take these two coordinates, so 5, 1, and then minus 0,
Do the slope triangle approach.
which one? Like this? X1, Y1?
When you work on your iPad, go into the Google Classroom and take screenshots and put it on the page so you can use the questions here. You'll find it easy. Okay. Don't be stressed. Find the best one. Find the best one. All right. Only half of you managed that in that time. You really shouldn't be taking more than around about 30 seconds to do a question like this. That means you need to do practice. You need to do a lot of practice for this, okay? You're not doing enough practice, you need to do more repetition because you can't be that slow. You are going to run out of time on tests if you think you can take that long to solve a problem as easy as this. So make sure that you take plenty of time to do plenty of homework practice. I think what I'll do during today's lesson is I'll substitute the AISLs and find a Khan Academy activity that we can work with. I'll do it today. For this technique, you want to use the slope triangle. In order to do it, we need to start by finding 2 points. So this is a great point. X is equal to 0, always a good start. You need to find where this line crosses the coordinate axes exactly. It crosses the coordinate exactly here, at this point. So this is the thing that we should use. So how long is this line here, from 0 to 5? How long is that line? 5. From here upwards, how many squares do we go up? 2. So the gradient for this one is what? 2 over 5. Okay. 10 seconds flat. It should not be taking you this long to do questions like this one. We need to be much quicker. Okay, a little bit more to read on this one. Have a go at this one, work together with the person next to you. I think we can have around about 5 minutes for this one. Okay, so we have a bit of a problem-solving question here now. So the points, we're given 2 points that fall on a line, and we're told that the slope is 5 over 9. The difficulty with this is one of the points has an unknown in it, but we can still use that. Let's, it doesn't matter which way around we put our points in. I'm going to, just because this is on the left, I'm going to take this as x1 and x2. I'm going to call this x1 and, sorry, y1, and this one x2 and y2. I'm going to put up the formula for the slope. The slope is equal to y2 minus y1 over x2 minus x1. Using this, I can put in the information for the question. We're told that the slope is equal to 5 over 9. We know that y2 is equal to 5. We know that y1 is equal to f. x2 is equal to negative 10. And x1 is equal to negative 1.
So you put -1.
Is equal to -1. We can type it in at this particular point into the calculator if we want, or we can do a little bit of arithmetic. I prefer to simplify it slightly. We've got 5/9. Most of it will be quicker for me to type it into the calculator. So I'm going to just do this. -10 plus 1 is going to be -9. I'm going to put this into the calculator. We can solve it completely by hand if you want, but if you find it quicker, you can use a calculator. Don't forget when you start on the calculator, what that is, the aliens trying to communicate with me. When you start on the calculator for a new day, generally what you want to do is to create a new page, a new document, say no to the previous one. Always start by adding a calculator page, and then decide what it is you want to do. We're going to end solve this. So we press menu, follow along on your calculator, so we press menu, algebra, end solve, use control and divide to get your quotient symbol up.
Should I switch to Y?
Switch to Y. Yes, this is horrible.
Yeah, 79 things just
5 minus f over -9. And then we press comma and say solve for f.
But don't do chem, whatever you do.
This tells us f is equal to 10.
Did you get it to 10?
Okay, discuss with the person next to you the question. Have a go at this. 5 minutes for this one. Okay, so we have roof regulations that state that asphalt roof tiles can only be used on roofs with a maximum gradient of 0.17. We've got the roof shown in the diagram. It tells us that the width is 7. So it means this is equal to 7, and it says that the rise is 1.6, so this is 1.6. So our slope is going to be the rise over the run, change in y over change in x. Now the change in y is 1.6, but the change in x is going to be 3.5, because this triangle is only half of the total roof. We put this into our calculator. What do we get from the calculator?
0.457.
So we get 0.457. So with questions that use the justify or the interpret, when you're trying to give a justification like this one, this is what we need to do, is we need to use an inequality. Typically, you want to use an inequality in a question like this. You want to put up the proof. So we've calculated the value here, and we say that 0.457 is greater than 0.17. So this inequality is what's going to get you the final mark on this type of problem. You have to give an inequality. We'll see a few questions on the course that require when you compare two numbers. So whenever you compare two numbers, you compare with an inequality. And this notation is required. What does that imply? So US roof codes state the asphalt tiles can only be used with a maximum. What's the interpretation from this question? So if we do the comparison, we then need to make the interpretation. Look.
They cannot get asphalt tiles because it's
Yeah, so this implies that asphalt tiles cannot be used. Okay, so this is our first interpretation question on the Applications and Interpretations course. There should be more interpretation questions, that there isn't. 1 in 10 questions at best. All right, that is us finished with our lecture for today.